Hello, my name is Brooke Goodland. I am a 4+1 student getting my bachelor's in biomedical sciences and my master's in biology. My biodiversity study focused on the riparian preserve in Gilbert, Arizona. For more information on this location, this map shows the preserve in reference to surrounding geography and zoomed in. The zoomed in map shows Pond 7, where the dry and wet regions were studied and compared. This study provided a lot of useful information, but I want to focus on the biogeography, functional traits, and ecological assessment results that were arguably most important. Biogeography is the study of patterns in species distribution. This was analyzed in the types of species and the density of them, comparing the wet and dry samples. Based on the calculations below, it was determined that though there were slight differences in abundance and diversity of the samples, the wet and dry areas were significantly similar with a final similarity index of 0.6. The functional traits of these plants were also discussed in my study, specifically the teeth in mule fat leaves that protect against cold weather. It was found that some of the sample lacked teeth on their leaves. It is hypothesized that this is due to the warm climate Arizona provides the sample. The Populus fremonti population in the dry area was found to be dehydrated and suffering from the drought. This made their functional traits to be capable of decreasing their leaf size for better resource allocation in drought much more noticeable, as seen in the images. The ecological assessment combined this information and placed vegetation accordingly, thus creating a sustainable preserve that can benefit the survival of vegetation and the ecosystem as a whole. The vegetation placed will prevent the species from becoming endangered through ex situ conservation. It also is shown to significantly improve air quality and conserve water through the 50-year estimates created in iTree and visible in the graph and data. But why does this matter? Biogeography's ability to assess and quantify patterns allows for accurate representation of what the environment does, has, and will look like. This can then be used, as seen in the ecological assessment, to provide important insights to conservation efforts. The functional traits aid in this pattern recognition as they provide insight about the type of environment a species can survive in. This is useful in determining past and current environmental conditions and deciding which species to plant in a specific environment during conservation efforts. This study has the greatest immediate benefit to Gilbert, Arizona, where information is provided about current vegetation, and the suggested ecological assessment shows a viable way to improve air quality and reduce water runoff. However, the information in this study can be used in areas with a similar environment as a guide, or the methods in this study can be easily reproduced to create a viable conservation plan for all locations. Thank you for watching, and I hope you enjoyed.